All right, let's dive into one of the most famously strange and honestly mind-bending ideas in all of physics, quantum entanglement. We're going to unravel what this spooky connection is really all about.
So, what is the strangest secret that's hidden deep inside the quantum world? Well, it's a phenomenon so bizarre that it seems to tear up the rulebook of space and time.
And that secret is, well, it's a kind of connection, a link between particles that seems to be instantaneous, and it just shatters our everyday intuition about how the universe is supposed to work.
Okay, here's the core idea. Entanglement is a special kind of quantum correlation. Let's say you've got two entangled particles. If you measure a property of one of them, like its spin, you instantly know the spin of the other one. And I mean instantly, even if it's on the other side of the galaxy. Now hold on, this doesn't mean we're sending information faster than light. The influence is instant, for sure, but to actually make sense of it, you still have to pick up the phone and call your friend across the galaxy to compare notes. The real magic is in that perfect, pre-existing correlation.
And this is the part that's so hard to get your head around. There is simply no analogy for this in our day-to-day world. Nothing you can see or touch works this way. It's a behavior that only exists at the quantum level, and it forces us to completely rethink what we mean by connection and distance.
So, if this connection is so unique, how do scientists even describe it? Well, they've got a very precise language for it, and it all starts with something called the Bell states. The best way to think of these? They're like the master blueprints for a perfect entanglement.
Now, I know this might look like a bunch of complicated math, but you don't have to worry about the symbols. The key takeaway here is actually pretty simple. This slide is showing us the 4 fundamental ways that 2 quantum bits, or qubits, can be perfectly entangled. That's it. These are the 4 distinct, perfectly balanced recipes for creating this incredible quantum link.
So the crucial point here is that these Bell states aren't just abstract math on a page. No way. They represent the absolute purest form of entanglement you can possibly have. When scientists talk about harnessing the power of this phenomenon, these 4 states are the gold standard they're aiming for.
This all might sound like magic, I get it, but creating entanglement in a lab is actually a pretty well-defined process. So let's take a look at the straightforward 3-step recipe they use to do it. Here's how it's done. First, you start with 2 qubits in a really simple known state. Easy enough. Next, you hit them with 2 specific quantum operations. A Hadamard gate, you can think of that as a possibility opener. It puts a qubit into a weird state of being both 0 and 1 at the same time. Then, a CNOT gate acts like the weaver, basically linking the fate of the second qubit to whatever the first one is doing. And finally, you measure the results to make sure that entangled link has actually been forged. And this right here, this shows you the result. It's night and day. If you measure 2 separate, unlinked qubits, their outcomes are totally random and have nothing to do with each other. But after you follow our recipe, the entangled qubits are completely different. Their fates are intertwined. When you measure them, their outcomes are perfectly correlated every single time. The randomness is just gone, replaced by a perfect shared secret.
Okay, so it's a spooky, perfect connection that we can create in a lab. But what's the point? Why does any of this matter? Well, it turns out this spooky connection isn't just a weird curiosity. It's an incredibly powerful resource.
Entanglement is literally the engine that's going to power the next wave of technology. It's the key to building hack-proof quantum communication networks, because if anyone tries to eavesdrop, they instantly break the delicate entanglement, and you know you're being watched. It's also the key to quantum teleportation. Now, we're not talking about beaming people around, but we are talking about transferring the precise quantum state of a particle from one place to another. And of course, it's the foundation for some of the most powerful algorithms in quantum computing.
Phew, we've covered a lot of ground, from spooky definitions all the way to real-world applications. So let's just boil it all down to the absolute core takeaways.
Here are the 3 big things to remember. First, entanglement is a purely quantum thing. Our everyday logic just doesn't apply. Second, those Bell states we looked at, they're the perfect textbook examples of this connection, the ideal that scientists are always trying to achieve. And third, and this is the big one, this strange property is a very real, very powerful resource that is unlocking the next generation of technology.
Which leaves us with a final, fascinating thought. Entanglement proves that the universe is connected in ways we're only just beginning to understand. Ways that defy our neat and tidy ideas about space and separation. So if this deep, spooky connection is real, what other fundamental secrets about the nature of reality are still out there, just waiting to be discovered?